Hi everyone. In the previous sessions, we have gone through about the PPIs, right? So to share the data between the PI phase to other PI modules, right? So, but those PPIs cannot be used in the Dixie phase. So then, how are we going to share the data between the from the PI phase to Dixie phase? We can take the help of the hops. So which means in the PI phase, we can create the hops and then we can assign the data structure with whatever the value which we wanted. And later in the Dixie phase, we can access. Maybe let me write a diagram, right? So assume this is our boot flow, right? So somewhere here, our sec phase is going to start, right? And then here our PI, maybe I would call it as a pre-memory phase is going to get started. Okay. And somewhere here our postmem will get start. And somewhere here our Dixie phase is going to start. Okay. So sec will start here. Pre-mem will start here. Postmem will start here. And Dixie, BDS and OS, right? So now we have gone through about the PPIs. So those PPIs is available from here to here, right? So now if there is any data which we need to transfer from premium or a postmem, so both premium and postmem call it as a PIM. Okay, so from this PIM phase to Dixie phase, we have to transfer some data, right? So how are we going to transfer? So we will take the help of the hops. Okay, so here in the premium or maybe in the entire PI phase, right? We will create the hop, we will assign the values, and later the Dixie hop can locate the hop with the help of the GUID, and it can so once the hop is located, so then ultimately whatever the data which we have assigned in the PIM phase can be used in the Dixie phase. Okay, so let's see how to do that, right? So I will open our folder structure here. So to have that, we need to have a GUID, right? So hop is associated with a GUID. Okay, so first we have to create a GUID. Okay, so I will go to emulator package.dec. Okay, so here we have a section called GUIDs. Okay, so here I will create a GUID. Insert GUID. I'll create a static GUID and I will change this to a comment. Okay, so let's see G sample of GUID. Okay, so we'll remove the semicolon at the end. So now we have created a GUID. Okay, so this is a simple way of creating a GUID. So now I will go to our emulator package.dftf. So let's pick any of this random PIM driver, right? So maybe let's take maybe our autoscan pi.inf. Okay. So first here we will create the hop. Okay. And once we create that hop, so in the same in the other PI driver, right? So we'll get the hop, print the data, and maybe in the other Dixie modules, maybe here or maybe runtime Dixie driver, right? So here again we will try to get the hop and print the data. Okay, so now we'll go to this autoscan PI. Okay, so now here we have to this now we have to create a hub, right? So to create a hub, we need a GUID. What is the name of the GUID? It's a G sample hub GUID. Okay, so now that GUID we have to include in this INF file. Okay, so do we have the existing section header called the GUIDs here? No, we don't have. Okay, so let's create one. So to create a section header called GUID, so it's simply open bracket within until close bracket. Within that we have the GUIDs, and here we are going to specify our GUID name, and this GUID here we are going to produce. Right, because here this is where our GUID is getting created or our hub is getting created, right? So simply we are going to specify this as a produced. Okay, so now let's go back to its C file. Okay, so now we have the GUID, right? So now this hub should be associated with some data structure, right? So now let's create a data structure. So under the EDK2 folder, we have emulator package. Under that, we have the include GUID. Okay, so maybe let's copy paste one of the structure and here sample hub data.h. Okay, so let's have this sample data hub. Okay, and here we have this hub, right? So probably we can replicate this in the in this format as well, but for now it's not needed for us. I will strip off. So under the so this action GUID. Okay, so let's specify that GUID as well here. Okay, so now let's create remove this. Okay, so now I'm going to have a uint 64 and then I'm going to have 232 uint 32s. Okay, so now variable 1, variable 2 and variable 3. Okay, so now sample sample hub. So my data structure name is a sample hub, which is going to have three members, which are variable 1, variable 2, and variable 3. Okay, so now let's access this header file, the hub data structure, right? So now I will go to its C file, auto scan. So let's include this header file, right? So this header file is under the GUIDs folder. And in this DC file, we have the includes path. So we have to provide GUID slash sample data hub. GUID sample data hub. Okay. So now we can access this structure. Okay. So now here, let's create a pointer star sample hub. Okay. So now let's create the sample hub, right? So now here debug underscore info. I will use some variable called BIOS just to identify from those logs, right, where exactly we have added the debug prints. Okay, and then I'm going to use a percentage %a to have the function name. Okay, so hop creation start. Okay, and here I will use a function. Okay, so now sample hop is equal to, so now we have to call a function called build void hop. Okay, so now this build GUID hop is going to take two arguments. One is our GUID. So address of what is our GUID name? Sample hop GUID. Okay, so we have provided a sample GUID hop and it is going to take the size. Okay, so let's go to its definition, right? Let's see. Okay, so PI, this is the, not this. Okay, so usually now it's emulator, it is going to pick here, right? So now here, so it is going to take the GUID and it is going to take the data length, right? So what is this data length? The size of a data payload for the GUID hop, right? So now what is this size? So it's our size of our data structure, which is sample hop. Okay. So now here, let's try to print the variable as well, right? So what this pointer is pointing to, right? So is equal to 0x percentage L X. Okay. So let's print this. So it will point to some memory location, right? So we will just print that memory location. Okay, so why we are printing, I will tell you that later. Okay, so now we can zero mem this structure for a safer side. But if you know that, so since my data structure is going to have only these three variables, and I'm pretty much sure that I'm going to assign all these variables. So then I simply have to assign it directly. I don't have to do the zero mem. So if you have the more members and at this creation of the time, if I'm going to update only one variable, then I have to make sure that I have to zero mem the other variables, right? So first we have to do the zero mem. Okay, so now as you can see during the creation of this data hub, we may not sure that the whatever the pointer which is going to give, right? So that pointer may have zeros or may not have zeros, right? So that's the reason we have to always make it as zeros if we have the more data structure, and if you are not assigning all the data structure in one place. Okay, so now as I know that I'm going to update everything here, so now I'm not going to do the zero mem. Okay, so now let's assign the variables, right? Sample hop variable one, I'm going to assign 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Sample hub variable 2. Okay. So I will assign 1, 3, 5, 7. Sample hub variable 3, 2, 4, 6, 8. Right. So now there's a simple way of creating a hub. So hub is created. So now we are going to assign the values to the data structure. Okay. So now let's try to build. Let's see whether do we get any errors or not. So I will do EDK setup. Okay. So EDK setup.bat. Then let's try to run the build command. Let's wait for a moment. Okay. So as you can see, it is builded, right? So now let's try check the boot test as well, right? So we'll go to build emulator x64 build fv. Okay. Okay. So here I'll go to FFS. No, sorry. We'll go to x64, and here we have our win host, right? I'll open the command prompt here, win host, and we will store it to boot.log, and we will store everything. Okay, so now it is booted. We'll do exit, reset. Now let's open the logs. It's in the build x64 boot.log. Okay, so here we have our BIOS keyword, right? So we have added two debug messages. So those debug messages are here. Okay, so hop creation and the sample data hop, which is here. Okay, so now as we discussed, so let's try to locate that hop in the firmware volume PI, right? So which is another PIM module. Now I will open this here. So now here do we have the GUID section? No, let's create one. Why we need to have? Because we have to locate the hub, right? Uh, so to locate that hub, we need a GUID. Okay, so GUIDs, and what is the GUID name? Let's copy the GUID name here, and here this GUID name we are going to consume it. Okay, so now let's go back to our C file here. Okay, so now here we need to locate that hub, right? So to locate that hub, we need to have the pointer to a hub list. Okay, so void hub list, or maybe simply let's say just an hub. Okay, and then we have our data structure name, right? So sample hub. Okay, so sample hub a pointer sample HOB. Okay, so now we have to include that header file, sample data HOB. Okay, so now first we have to get that first GUID HOB, right? So HOB is equal to get first GUID HOB, right? Because so that same GUID can the HOB can be installed multiple times, right? And as I know that this is the first time which only one time that the HOB has been installed, so I'm getting the first instance of that HOB. Okay, so we'll get the first instance and we will simply pass the GUID name. So what is the GUID name? It's a gsample HOB GUID. Okay, so now this is a HOB which is pointing to this data structure. Okay, can I use this HOB directly to find my data? No. So I have to from this HOB I need to go to its a data structure, right? So what is the ultimate data structure which I have to go for? It's a sample data HOB. Okay, and let's typecast it, right? So which is a pointer, and that pointer I have to typecast it to this data structure, sample HOB. Okay, so now there is something macro called get GUID HOB data, right? And for this I have to pass the HOB. Now this will make sure to get the data structure pointer which I'm looking for. So if you look at the implementation of this, so we have the HOB list, the start of the HOB list we are passing, and internally it is going to add the size of this HOB GUID because it so now so since we are relying on the GUID, right? So now so that GUID has to be stored somewhere, right? So which means from the start address plus this data structure will be appended. Okay, so which means if I go back to my data structure here, right? So now this data structure has to be pointed to some GUID, right? But now, so since we don't have any GUID here, so this has to be stored associated with the GUID. Now, so when creating a pointer, so that HOB will append a data structure, fi HOB GUID, and it will start from there, right? So since that entry it is not here, so we have to get the HOB GUID which is pointing to our data structure, which means we have to exclude uh, this variable, right? So we have to exclude this EFI HOB GUID type, right? So to do that, so we can simply call this preprocessor directive called the get GUID HOB data. Okay, so now let's try to add the debug messages how we have added earlier, right? So where we have added here. Okay, so here get HOB data. Okay, and let's try to print this as well. Sample HOB, we will print it. Okay, so now along with that, we'll try to print a variable as well. Variable one, okay, sample data HOB, and then variable one. Now we'll print the variable two. Okay, so now let's print the variable three. Okay, so now let's try to run this build command. So I just simply ran the build command. Let's wait. Okay, so build is completed. So now let's try the boot test. Okay, it is done. So now let's go back to the logs. There is a logs boot.log. Okay, so now let's search for a keyword, right? So we have 7 instances. BIOS. So here the hub is created, and then here we get the hub, and it is pointing to the data structure, right? And this is the content of the data structure. So as you can see, this is the same data which we have assigned earlier. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. The same data can be visible here. 1357, 1357, 2468, 2468, which means we have created a data hub in this PI driver, and in the other PI driver, we have located that hop and we have printed that. So if you might have noticed from the logs itself, right? So this sample data hop which I printed, right? So here it is pointing to 22F999B0E38, right? And here I can see that address has changed, right? So why it has changed? Maybe somewhere here you can see we have migrated from the temporary memory to a permanent memory, right? So the hops can retain the data even after the temporary migration. Okay, so even when the data is migrated from the temporary memory to the permanent memory, we don't have to worry because our EDK2 services will take care of migrating the hop data as well. Okay, so now let's get the same data in the Dixie driver, right? So here maybe let's choose one of the driver, right? So here runtime data. Maybe let's see is there any other driver which we can use. Maybe here let's take this Metromin, right? So do we have any logs? Just I don't want to mess around the debug libraries at least for now. Yep. So maybe we can pick this. Okay. Okay. So same thing, whatever we did, right? So for the firmware volume PI, we'll do the same thing. We'll get the GUID. Do we have the GUID section here? We don't have GUIDs. And then we have to include a header. Let's include. Okay. And then we need to have that hop GUID. So let's have, where is our entry point? I believe this is our entry point. Okay, so now we need to get that hop. Let's get the hop and we will print it. Okay, so we have this hop, sample hop. We will get the first GUID hop and we will get the data from that hop pointer and we will print it. So now this is in the Dixie, right? Now let's again build it. Okay, so now here, let's see. Okay, so here we are doing in the MD module package. Okay, should be fine. So now this G sample GUID, right? So this is coming from the emulator package, right? So now we have to make sure this emulator package DC file should be included here. Okay, so probably we should have created in the emulator package itself, but for now should be fine. Let's add that here, build it. Okay, so now we got the error, right? What is the error here, right? So here we have this get hub, right? So it is undefined. Okay. So why it is undefined? So we have to use here as a hub lib, and here we have to include the hub lib libraries, right? Library slash hoblib.h. Okay. So now let's try to build it. Okay. So this time it is built it. Okay. So now let's try the boot test as well. Okay. So it is booted. Now let's go back to the log. Where boot.log closed. Okay, so we'll open this boot.log and we'll see here the logs did not came. Why it did not came? Because of the serial library. Okay, so either we have to change the serial library or we have to choose the other module. Okay, So let's try to change the serial library itself. Okay, so the one which module which we have used is this one here, right? So now let's go back to our DSC file. Okay, so now here we have to explicitly mark the serial library. Okay, so how are we going to explicitly use the customized serial library? So library classes, and then here the serial library we have to specify. Okay, so now let's see, right? So which are the serial libraries are available? By default, it is null, and this is a PI. This is also a PI, and here for the Dixie, we need to use these two libraries. Okay, so where is our driver? Here. So we will use these ones. Okay, so base debug port serial leave and the Dixie standard error serial port leave. So now let's build it. Let's wait for a moment. Okay, it is built it. So now let's try to run the same command, min host. Okay, so now let's see. Did we have received the logs this time? Hmm. Now you can see we have received the logs now. Okay, so in the install metronome, so we have the sample hop, and we can see the same data has been retained here. 1 2 3 4 5 6 7 8 9 1 3 5 7 2 4 6 8. So if I look at here, you can see, right? So this whatever the data which we have created, which we have assigned in the PI phase, can be same used in the Dixie phase as well. Okay, so if I go back to that same diagram, so we have created a hop here. Okay, and we printed that hop somewhere here. The data is retained, which means the same data is available. And then again, we got the same data here as well in the Dixie phase. Okay, so this is how we can transfer a data from the PI phase to a Dixie phase with the help of the hops. That's it for today. Thank you.